Okay, we've got PDM connected, ignition on. Now I can fire the software up. Connect to COM3. PDM connected. I have to wait for this on my ancient laptop. This status screen gives me live current for all the channels, and what I can do here is override. So I'm not using any inputs on the PDM, just overriding low pressure fuel pump. I have filled the tank with 20 litres of petrol, disconnected the fuel pumps, so I'm just going to measure this and be back with you in a minute. So I've got 12 volts on the low pressure fuel pump supply. Now I'm going to turn it off there and connect the pump back up, run it up, see what happens. Moment of truth. Try again. Fuel pump current. I can hear fuel sloshing. Swell pot's filling up. I also can't see any fuel anywhere, so that's a good sign. Hey. Now that pump's not too bad actually, it's quite quiet. So this should now, the swell pot should now fill up, and it's a circuit, so it goes back into the fuel tank, and the low pressure pump keeps that low pressure circuit going to supply the high pressure pump. So I will now turn the low pressure pump off. That's good, look at that, look at that. So we're pulling about 3 amps max. Does it say on there? Yeah, it's all over the place, probably needs a little bit of smoothing on that value. Okay, I will connect the high pressure pump and see what we've got. Okay, so high pressure fuel pump did run, had a bit of a leak here, that tuber leak not tightened up properly, so that's sorted. Bit of a leak around there though as well. The high pressure fuel pump's faulted at the moment because it went over current. Low pressure fuel pump's fine, but the high pressure fuel pump is reading 50 amps and faulting out. I don't think it's actually reading 50 amps, so next step is get my oscilloscope on the case with the current clamp and see what current it's actually drawing. So I ran the high pressure fuel pump up and managed to capture a decent waveform here. So it's on 10 millivolts per amp, so we're peaking at 19 amps, that would be these peaks here, and it's continuously running at about 5 amps, just below average, which is more like what I'd expect. It's not loaded at the moment because I've backed the pressure relief valve right off, so that pump, the only load it's got is just circulating to the front and back. So my PDM needs some work to measure inductive loads more accurately, and so I think that's probably it for today. I'm going to sort this little leak out here. Just needs a bit of tape around that thread, and then it's back up to the workbench to carry on with the software on this PDM. Once that's sorted, I can run the high pressure pump in anger and set the pressure, but that's good. Productive day, I reckon. There is one more thing I wanted to run actually, which is a radiator fan. That's another inductive load. I did just run it there for a second without filming it, but there we go. It's a Spal fan, it's pushing some decent air through, so I'm happy with that. You can see there's big inrush on there, big inductive load. That's pulling 20 amps there. But with the way it's configured, it's got a half-second delay at the moment to ignore that inrush, so it actually runs okay. I guess because the fuel pump is kind of constantly on and off, then that's something I need to deal with as well. That could increase a bit for the radiator fan. It's only on half a second. I could put that up to 2 seconds. That's what I've configured for it. But so that's just something else. Let's just see what that was actually pulling. Just run it up again. There you go. It had a little stumble there, so I will increase the inrush time for that. 6.8 amps seems about right, so maybe not as inductive as the high pressure fuel pump, or just the fact that it stays on, and actually the high pressure fuel pump turns itself on and off, so that's probably part of the problem.